The question says, what is the probability of getting at least 1/6 if a dice is rolled 2 times? So the probability of at least 1/6, this is rolled twice, that's what we're asked to find. So what are the combination of rolling the dice twice? Now we're looking for 6. So the combination can be 6 and 6 because it's rolled twice. It can be 6 and not 6, and it can be 6, it can be not 6 on the first and 6 on the second. So these are the only 3 situations where we can have at least 1/6 if a dice is rolled twice. So the probability of having 6 on the first try would be 1/6 because there's 6 sides, and again 1/6 for the second try. So since it's and, it's multiplication. So that would be first possibility. The second possibility would be or. The first draw would be a 6, which is 1/6. And the second draw is not 6. So not 6 would be anything other than 6. So there's 5 other numbers. So we would have 5/6. Or not 6 would be 5/6 and 1/6 for 6. This would give us the probability of getting at least 1/6 if a dice is rolled 2 times. Now, as you can imagine, this would become really tedious and almost impossible to do if the number of times the dice is rolled is increased substantially, like 20 times or 100 times. It would be impossible to do this by hand. So we're going to use a different method to make this easy for us. So the probability, so we're going to do it here. Probability of at least 1/6 would be 1 minus probability of no 6. To the power n, where n is the number of throws. So if we use this, we will get 1 minus probability of not is 6 would be 5/6, and the number of throws is 2, and this will give us 0.306, which is the same number as 0.306 here. So these are the same number. So we prefer to use this method because this is much easier and we can do it for any number of throws. So this was question A. Question B says, what is the probability of getting at least 1/6 if a dice is rolled 3 times? So now here n is 3, and we can do the same thing. P of at least 1/6 equal 1 minus probability of no 6 to the power n. In this case, n is 3. 1 minus 5/6 to the power 3, and this gives us 0.421. The last question says, how many attempts or throws are needed if the probability of getting at least 1/6 is 0.9? So in this question, probability of at least 1/6 is given, which is 0.90, and we can write this, we can equate this to 1 minus 5 over 6 to the power n, which is the number of throws. If we solve this for n, we will find the number of throws that's needed to get a probability of 0.90 for at least 1/6. So let's solve this. We will have, let's rewrite this, 1 minus 5 over 6 to the power n equal 0.90. 5 over 6 to the power n equal 1 minus 0.90, which is 0.1. We can take log of both sides, equal log of 0.1. We can bring n to the front, so we have n log 5 over 6 equal log 0.1, and then n equal log 0.1 over log 5 over 6, and this gives us 12.63. So we need at least 13 throws to get a probability of 9.0 of getting at least 1/6. So that's how you do it.